Okay, with us here we have a logarithm question. It says log x equals to x squared over 25. This is kind of hard to solve algebraically. It is even not possible. So there is a method that is called the Lambert W function. We can actually use that to solve this equation. I know I've been posting a lot of logarithm questions. I really love logarithm equations. So let's solve this with the Lambert W function. And I should state the Lambert W function at first. The Lambert W function states that if x times e to the s the Lambert W function states that if x times e to the x is equal to y, then x is equals to the Lambert function of y. Note, e here is the Euler's constant, the e that normally goes with the natural logarithm. This is the e that normally goes with the natural logarithm. So if the Lambert W stays just as this, then we should make this look like this. But that is not quite too easy. But we can actually do that. So that is why we are here to do it together. So cross multiply, you have that solution. Cross multiply, you have that 25 log x equals to x squared, right? But 25 can be written as 12.5 times 2. So we have 12.5 times 2 log x equals to x squared. 2 can actually come here. Then you see 12.5 log x squared equals to x squared. So now from here, we have x squared here and also here. Why not make x squared something like let x squared be y? So if we say let x squared equals to y, then we have 12.5 log y equals to y. So from here we can as well bring this again to this place. So we have log y raised to the power of 12.5 equals to y, right? But by removing this log, we say y raised to the power of 12.5 is equals to 10 raised to the power of y. Just has to get rid of this log. Then you see y raised to the power of 12.5 is equals to 10 raised to the power of y. Now actually I remove this log because I don't have any work with it, because we are actually working with natural logarithm when it comes to the Lambert W function. So now I want to introduce the, the, the natural logarithm. So by logging both sides and taking this to the back, you see that 12.5 ln y is equals to y ln 10. You know, by taking this to the back, you see, and by taking this to the back, you see 12.5 ln y equals to y ln 10. So now I want to take those that that are with y in them to one side of the equation. So you see ln y over y is equal to ln 10 over 12.5. This is by after cross multiply, after dividing both side by y, and as well dividing both side by 12.5. So you know that lane y over y is to lane 10 over 12.5, right? So there you say y here at the denominator can be written as y to the negative 1 lane y is equal to lane 10 over 12.5. So now I want to introduce the the e value. So if I am to introduce the e, I want this to be written as e raised to the power of lane y raised to the power of negative 1, right? Times lane y equals to lane 10 over 12.5. Yes, this is very legit. If I replace y raised to the power of negative 1 as e raised to the power of lane y raised to the power of negative 1, you know, e here can actually cancel out this lane because they goes together. So if e can cancel out lane, we'll be left with y raised to the power of negative 1 just as it is here. So nothing really changed, but I just want to get something similar with this. So if e raised to the power of lane y raised to the power of negative 1 times lane y equals lane 10 over 12.5, I can actually take this to the back as well. So I have e raised to the power of negative 1, which I may just leave as negative lane y times lane equals to lane 10 over 12.5. So now I want this to be here just as x is at the back of this one. So I say lane y times e raised to the power of negative lane y equals to lane 10 over 12.5. If you should look closely, they are almost the same right now, but this has a negative and this does not have. So how can I introduce a negative sign to this? So I multiply both sides of the equation by negative 1, right? So if I should multiply both sides of the equation by negative 1, I have negative lane y times e to the negative lane y equals to negative lane 10 over 12.5. So now they are both negative at both sides of the equation. So from here now, we already know the rule that says x times e to the x when it is equals to y, then x alone is equals to the Lambert function. This notation, this value of this w rather, this w is the notation for Lambert W function. So if that applies here, now we know that the x here that is here is negative lane y, right? So then then we have negative lane y is equals to the Lambert W function of negative lane 10 over 12.5. Yes, that is what the Lambert W function actually states. So from here now, you know that by dividing both sides by negative 1, so you say lane y equals to negative Lambert W function of negative lane 10 over 12.5. So now, by taking both sides, by by removing lane here, you see y is equals to e raised to the power of negative Lambert function of negative lane 10 over 12.5, right? So now you know that y is x raised to power 2. Yeah, y is x raised to power 2. So now we are actually we're actually looking for x. So you say x squared is equals to this, because y is this, then x squared is this. So x squared is e raised to the power of negative Lambert function of ln 10 over 12.5. So x therefore is equals to the square root of e raised to the power of negative Lambert function of negative ln 10 over 12.5. So this is our value. This is our value for x.